Welcome to the Explainer. Have you ever looked at a screen full of code and just seen, well, chaos? Today, we're going to untangle that. We're diving into the powerful scripting language TCL, breaking down its core building blocks, step by step, to turn that confusion into code that actually makes sense.
Right, so this is where it all starts for pretty much every programmer. Hello, world. It's about the simplest instruction you can give a computer. The command here, puts, which is just short for put string, tells the computer, hey, display this text. It seems tiny, but this one little command is our gateway to everything else.
Okay, so that hello world was a simple one-off command. But the real power in programming isn't just about shouting one instruction at a time. It's about giving the computer a memory, a way to hold on to information so we can use it later. And how do we give a computer a memory? We use something called a variable. And honestly, it's a super simple idea. The best way to picture it? Think of a labeled box. You give the box a name, and then you can stick a piece of information inside, a number, a word, you name it. And check out how straightforward this is in TCL. We use the set command. So set marks 80 is basically us telling the computer, hey, make a box, label it marks, and put the number 80 inside. Now, the really important part is getting that value back out. For that, we use the $sign. That little symbol tells TCL, don't give me the word marks. I want what's inside the box, named marks. And that's why puts $marks prints 80. So we've got our data stored in a variable. Now what? Just having it sit there isn't very useful, right? We need to actually do things with it. And that is where operators come in. You can think of these as your basic toolkit. You've got your arithmetic operators for doing math, your relational ones for comparing things, and logical operators to combine those comparisons into more complex questions. Storing data and doing simple math is useful, for sure. But the real magic, the thing that makes a program feel, smart, is when it can start to think for itself. This is where we give our code the ability to make decisions and to repeat actions. This is all about controlling the program's flow. So what's the big question here? How can a program look at a situation and decide to do this instead of that? It doesn't have a brain, obviously, but we can give it a very strict set of rules to follow that makes it seem like it does. And the answer is the good old if-else statement. It's basically a fork in the road for your code. First, you set up a condition, a test, using those operators we just talked about. Something like, hey, is the number in the marks box greater than 50? If the answer is yes, or true, the code in the if block runs. If the answer is no, it just skips that and runs the code in the else block instead. It's that simple. It's the most fundamental way a program makes a choice. Making a single choice is a huge step. But what if you need to do something, say, 100 times or 1,000? You're not going to copy and paste the same code over and over again. That would be insane. That's what loops are for. They are the automation workhorses of programming. Now, TCL gives you two main flavors of loops. A while loop is perfect when you don't really know how many times you need to repeat something. It's like saying, keep doing this while this condition is true. A for loop, on the other hand, is much more structured. You use that when you know exactly how many times you need to go around, like do this task precisely 10 times. And you get even more control than that. Think of the break command as your emergency exit. It lets you just bust out of a loop instantly, no questions asked. And continue is kind of like a skip button. It tells the loop, okay, we're done with this current round, jump straight to the next one. These are super useful for handling unexpected situations. Okay, so up until now, we've only been dealing with one piece of data at a time. A single number, a single word, but that's not really how the world works, is it? Information usually comes in groups, a list of names, a bunch of stats. We need a way to handle these organized collections. The most basic type of collection is a list, and it's exactly what it sounds like, an ordered collection of things. The perfect analogy is a shopping list. The order you write things down in actually matters, right? That's a list. And of course, TCL gives you a whole set of tools to work with these lists. You can use LLappin to add a new item to the end, LLength to check how many items are in there, LIndex to grab an item from a specific spot, and even LSort to sort the whole thing. But what if the order doesn't matter? What if what you really need is a way to look things up by a specific name? For that, we have a dictionary. This isn't about position 1, 2, or 3. It's all about key-value pairs. You have a unique key, which is like a word, that you use to look up its associated value, which is like its definition. For instance, imagine this dictionary represents a user profile. If we want to find the user's name, we don't ask for item number 1. No, we ask for the value associated with the key name, and boom, we get Jolt. We look up the key ID, and we get 80. It's just a much more descriptive way to organize related bits of information. All right, let's take a quick look back. We have variables for memory, if statements for making decisions, loops for repetition, and now lists and dictionaries to handle complex data. We've got all the pieces. Now for the final and maybe most important step, packaging our code into reusable tools so we're not constantly reinventing the wheel. We do this with something called a procedure. You might have heard it called a function in other languages, but the idea is the same. It's a block of code that does one specific job, and you give it a name. Then, whenever you need that job done, you just call it by its name. Here, we're literally creating our own command. Proc add defines a new procedure called add. It's set up to take 2 inputs, which we're just calling A and B for now, and the code inside those curly braces, that's the job it does. In this case, it just adds A and B together and returns the result. Simple as that. And this right here is the key to writing clean and efficient programs. You stop thinking about individual lines of code, and you start thinking about building your own personal library of tools. Once you write that add procedure, you can use it anywhere you want, just as if it were a built-in TCL command, like set or puts. So, there you have it. We started with a single variable and worked our way all the way up through logic, loops, data collections, and finally creating our own reusable tools. You know, these aren't just the building blocks of TCL, they're the fundamental concepts behind almost any programming language. You now have the grammar and the vocabulary to talk to a computer. So the only question left is, what are you going to build with them?